Okay, today on the bench, we do not have a priority mail radio. This is a Utica T&C II, or Town and Country. Hard to tell without the speaker grill, which is just kind of held in by the cabinet, so that's why it's off. I gotta do something about this fossilized foam that's, yeah, now kind of hard as a rock, but turned around here so you can see it. So there's the speaker grill for it, and you can definitely tell it's a vintage radio just by looking at the artwork. Yeah, when's the last time you saw, I don't want to say stick figures, but graphics like that on something? Just kind of cool. So the customer sent this in to have it restored a long time ago. This radio has been my arch nemesis. and it was no different once I actually got dug into it. So the first and the major problem was the customer sent this in and he did not have a power cord. And this radio uses, I don't want to say it's the oddest or the rarest power cord of any CB radio, but man, it's got to be close. I searched and searched and I just couldn't find any. So I put out feelers to everybody I know that deals with not just CB radios, but old amateur radios, AM shortwave radios, anything old and electronic. Deafening silence of crickets. It was like, wow, there's just none to be had. But I had sent out pictures of the socket on the back of the radio with dimensions and sent it to a bunch of people and said, if you see one, pick it up. I gotta have it. I don't even care if there's no cord attached to it. I don't need the cord. I put a new cord on it anyhow. I just needed the plug itself, though. So obviously the radio's turned on, so we have one. Now some people may be saying, well, Mike, why didn't you just put in a different plug-in socket? Well, I tried. I didn't actually do anything to the radio, but I went through every plug socket combination that I had here in stock, which is a rather vast array of them. I even ordered, I think, 3 different ones. I ordered some other Cinch Jones plugs and some, I think one was a Cinch Jones, one was an Amphenol connector, and I don't even remember what the heck that third one was I ordered. But it's just the size format, the hole that it had to fit in. I really couldn't enlarge it any. It can't go too far into the radio. It was just, yeah, just the physical constraints. It needed the plug and socket, or as far as the radio is concerned, the plug or the socket, whatever you want to call it, that's in the radio, that's what it needs to be. So, any case, I got it. I could start actually working on the radio now. So, customer wanted basically caps changed, replace the high wattage resistors. Wanted to know if there was anything I could do for the chrome cover, which once I get done the overview of the radio, I'll actually reassemble it so you can see it in the housing. It's a solid metal cover. Well, not solid, it's perforated, but it's a piece of metal, but it's completely chrome plated, and it was pitted pretty bad. I shouldn't say too bad, but it was severely pitted, a lot of small pits, and it was just nasty. Whatever atmospheric gunk had stuck to that thing decades ago and got baked on, man, it was on there. I tried rubbing with a little bit of polish, and yeah, that just, forget it. So luckily I have Baldor buffers here, big commercial buffers. So I put on like a, God, I think that thing's like a 2.5 or a 3-inch wide closely sewn buffing bonnet, so it's really hard because they're tightly stitched together. And yeah, a couple minutes on that 10-inch buffing wheel, man, and it took all that stuff out. So the cover looks a lot better now. Of course, it's chrome, so the slightest imperfection in cracks. The only thing I hate about really shiny stuff like polished aluminum or polished chrome, the slightest imperfection is just magnified. So yeah, trying to look at it under a lot of different lights here, yeah, it's going to look like somebody went over it with a piece of sandpaper. But like I said, it does look good. And like I said, I'll get her put back together. So the other thing, and the reason I say this was my arch nemesis, not so much for the plug. I figured eventually out, and I told the customer, eventually I'll find one. It's just a matter of finding somebody that has one, that wants to actually sell it. The big problem was, though, this radio, it is a Town and Country II. The problem with it is it's not that Town and Country 2. It looks very similar on the inside, but yeah, there's just as many differences as there are similarities. The original radios in the the original version of the radio. So from the outside, there's really no way to tell which one it is. Now I'm assuming maybe with the serial number, and I'll show you the back of the radio. Maybe with the serial number, I think they have chassis number engraved in the back. There might be a way of telling, but yeah, basically it's kind of hard to tell from the outside which version it is. So what makes this so drastically different is there's a vacuum tube missing that would normally, there'd be a hole punched right here, and there'd be a vacuum tube socket. And there would also be a big hole right here in a socket for a relay. And notice, there's just no relay up here. There is a relay, it's really small, and it's on the underside. So they made drastic changes in the relay circuit. So this is just a scan of the manual, or the schematic out of the Sam's manual there. And you can see on the original design of the radio, there were actually 4 sets of relay contacts. So we've got 2 sets of contacts here, so 1, 2, and then 3, and 4. Where this radio only uses, now the relay they have in here has 3 sets of contacts, but basically if my fingers are the contacts, what they did was, on the terminals for those contacts, they just ran a piece of wire through and bridged all 3 of them together. So all they're doing there is, you know, if a contact's rated for a certain amount of current, well, if you use 2 of them, it's going to double the amount of current it can handle. If you use all 3 of them tied together, it'd be 3 times the current it'll be able to handle. So that's basically all they did. They just took a 3-pole relay and turned it into a beefy 1-pole relay. Now that so much wasn't the problem. The problem was the power supply, because the power supply is completely different than what's shown on this schematic. So the rest of the radio, yeah, there's lots of circuit differences, the relay, you know, even some of the audio circuit and the transmit circuit and whatnot. The layout is a lot different on the underside, which I'll show you, you know, from what would have been original for one of these radios. But the power supply, yeah, it's just 100% different. Different transformer, different vibrator. So yes, this does have a vibrator, and no, get your mind out of the gutter. It's not that kind of vibrator, people. This is an electronic vibrator. So you can, which allows running something like this on AC, or if you're running on DC, that's what the vibrator does. Basically simulates AC. And they vibrate. That's why they're called vibrators, because if you put your hand on it, it'll sit there and vibrate, because it's actually a contact in there moving back and forth. But it's a different vibrator than what was originally used. This had a diode vacuum tube, so instead of having solid state diodes, this used a vacuum tube, because of course this is a vacuum tube radio. But one thing of note, there are 2 transistors in here, and the original version of the radio also had 2 transistors right here. These are used for, I think this one's an oscillator transistor, and I think this one's, well, right here on the schematic actually, oscillator. I think the other one's a mixer. No, oscillator amplifier. So yeah, they're using one of them is an oscillator and the other one's is an oscillator amplifier. And just looking at those transistors, the style, that gives away the age. Even more so if I pull one of those out, because they're actually just in sockets, kind of like the vacuum tubes. But if you pull one of those out and look at the name on it, these were made by Sprague. So yeah, the people that most people are commonly, you know, familiar with their capacitors. Yeah, they actually used to make semiconductors back in the early days. So yeah, those are actually Sprague transistors. But yes, my major differences, let me just zoom in here a little bit. I'll just lay the paper down. So the big problem was the transformer is completely different as well. Now, if it had just been they replaced the diode tube with solid state diodes, hey, that's no biggie. It's just a diode. Doesn't care if it's heated with a heating filament or if it's a solid state device. They both do the same thing, AC in, DC out. But yeah, the transformer is different. So all the wire colors are different, and not only that, this original radio, not this one, the original one here on this schematic could be used with 120 volts, 6 volts, or 12 volts. So it could run off of 3 different voltage types and forms, AC, and then 2 forms of DC, 6 or 12 volt. This radio will only run off of 120 or 12 volts DC. This was the early original radio, and the reason it had 6 volts was because, remember, for those of us old enough to remember old cars, now granted, they weren't around when I was alive, but I've worked on them before and very familiar with them, but vehicles originally had 6 volt operating systems, which eventually was increased at one point to 12 volts, which is what most people are familiar with. So yeah, this radio would work on all 3. This one's only 2. So they went with a different main power supply transformer and removed some windings. So yeah, it was just a matter of look in the radio and go, yeah, I'm screwed. I'm going to have to reverse engineer it. So that's exactly what I ended up doing. So I ended up basically going through disconnecting. Now luckily a lot of the windings on the transformer all go to that multi-pin plug, because that's what the plug does. Even if you look at the original, it's going to do the same thing. There's lots of jumpers in there. Okay, and what they're doing is that's how they're routing the power through the transformer, which taps they're using. That's all done with this multi-pin plug, and depending which plug you have plugged in, has different terminals shorted together. So I basically had to reverse engineer that. And like I say, the easiest way to do that is disconnect the windings. Advantage there, most of them go to the plug. There was like 4 other, which I think was basically the input or the primary and the main high voltage secondary winding. Just disconnected those, and then just with an ohm meter just go through and check for continuity. So even if you look at this, because this is the original paper I did it on, you can see I've got some numbers here. Those are actually resistance measurements I was taking. So the first thing you do if you're trying to figure out wiring for a transformer is, with an ohm meter or just a continuity tester, go through and find which wires that go into the transformer have continuity with any other wire, and then group them together. So for the AC input, you're going to have 2 windings. So you find a pair, it's a pretty good chance those are going to be, that's where your AC mains is going to hook up. If you find 3 windings, that's usually going to be your high voltage center tapped output voltage. And then most of the other windings, if you find 4, or in the case of the original, it had 6, because remember this one would also operate off 6 volts. But all the rest of these windings, you're going to find continuity. Now, once you find which 4 of these have continuity, you still need to figure out which ones are basically the ends and which ones are the taps. So the easiest way to do that is if you have an ohm meter that's very accurate. Now I'm using usually either a 5.5 or a 6.5 digit multimeter, so it measures down way down into the sub-ohm readings. And with a good set of Kelvin clips, what you can do is take very precise resistance measurements and figure out what the windings are, because between contact 5 and 12 I had 0.039 ohms. Between contact 5 and 14 I had 0.182 ohms. And then I'd be measuring like between this terminal and this one and here, but you just go back and forth, and it's just a process of elimination. You can figure out the lowest resistance are going to be a pair of windings that comes in here and goes straight out, and then if you start at more resistance in circuit, that's going to mean it's had to go through more windings in the transformer. So yeah, just a process of elimination. Like I say, basically reverse engineered the power supply, how it was hooked up. Same thing for the vibrator, because like I say, the vibrator in this is also different. This one only uses three terminals. Actually, there's 4 terminals on the bottom of this, but they're only using 3 terminals for this vibrator. Figure out the tube filament wiring, which that's a whole nother thing I'll get into. So the filaments, again, unlike this original one, which the filament layout was pretty straightforward. They're AC, so the transformer has output for the filaments, and it's basically the way they had it originally was pretty straightforward. Now I'm not sure why they did this. They may have, I'm just looking at this right now, they probably actually did that because of the 12 or 6 volt plug, because when this radio would have been plugged in, or this or the original radio, when they're plugged into DC, the filaments will then be running off of DC voltage instead of AC voltage. So yeah, that's probably why they had this wired. Some of them were direct, so they come through voltage to the filament and then to ground, filament to ground, filament to ground. But the rest of these here, you can see it goes filament, and then the return path is back through this plug, up the winding, and then down through to ground. But yeah, the windings on this, yeah, they had it wired even more wacky. So this is putting out 12 volts AC for the filament circuit. But all but one of the tubes in this radio are 6 volt. There is one 12 volt tube. So even a 12 volt tube's still 6 volt filaments. It just happens to have 2 6 volt filaments. But the way they had that wired is, so you'd have all of the power comes in through connector 4, or pin 4 in the connector in the back of the radio for the supply the voltage to the filaments. And you can see it would go through, like the tube V7 here, it would go through the filament. But it has multiple paths that it can take to go to ground. And that's what kind of, I'm not sure why they did that. So, you know, it could go up through V8, so it would drop 6 volts here, go up through V8, drop the other 6 volts to ground, or it could go through V7, then over through, let's say, half of V5, drop the other 6 volts to ground, or it could come over to like V3. It's just weird the way they had this. And what I have here for color is the brown wire that I'm showing here is actually the brown wire in the underside of this radio. It's kind of hard to draw on white paper with a white pencil and be able to see it. So all of the orange lines on here actually represent what are the white wires on the underside of this radio, and then the greens are where the tube sockets are tied directly to the chassis for ground. But, you know, got all that figured out. So I replaced the electrolytic capacitors, replaced the couple high wattage resistors in it. Now, a lot of people would be tempted, okay, we're ready to plug it in and fire it up. Stop. You don't want to let the magic smoke out. Magic smoke's not a good thing. Magic smoke is expensive. But, well, it's not so much the smoke is expensive, it's just expensive putting it back in. So what you want to do when you're doing something like this, where you're working with basically an unknown power supply and you're starting from scratch, having to basically build it back up to figure out how it's wired and whatnot, the first thing you want to do is take all the tubes out. Plug it in, but when you plug it in, now you should be running, of course, anytime you're working on vacuum tube or anything AC for that matter as a tech, you should be using an isolation transformer to protect you from being electrocuted if you accidentally touch something. But you know, here I use a AC isolation transformer, which is also a variable power supply. But the other thing that I did for this, before I powered it up the first time, because even after doing all this, we can all make mistakes. I could have gotten a pin out wrong somewhere, and last thing I want to do is turn this on and vaporize this, you know, unobtainium transformer. So I want to run this on a current limit as well. Easiest way to do that is with just what they call a dim bulb tester. So you can Google that, or you're already here on YouTube. You can just go into YouTube search and just type in dim bulb tester. I think pretty much anybody that works on tube radios has made one and has them. All it is a light bulb. Literally just a light bulb, like you screw into your ceiling. But it needs to be an old style incandescent bulb, you know, kind of like that, but 120 volt light bulb. The advantage of using a light bulb is only so much current can pass through that light bulb. When you screw the light bulb into an outlet, you know, in the ceiling, the amount of current that's going through that light bulb, that's the most that can ever run through it. It doesn't matter what you put. So if you break the line to that light bulb and insert, let's say, a radio in series with the light bulb, no more current can flow through that light bulb than the way it was wired normally, which was direct to the AC line. So it just, the filament in the light bulb acts as a current limiting device. And it works really well, and it's cheap. All you need is a socket, a plug, and a light bulb, and some wire. And that's literally it. You've got your current limit device. Now I've got a fancy one. I've got a bunch of different light bulbs with switches to be able to turn them on and off in different combinations, but it's just that simple. But like I say, that'll help prevent you from frying stuff like transformers. So once I was ready, I plugged it in, had it hooked up, and then just slowly started to bring up the voltage. And what you want to do when you turn it on, what you want to be monitoring in the power supply, you're going to want to be monitoring, especially in something tube type, the high voltage. You want to see if you've got high voltage starting to pick up. So, you know, by the time I got to like 10 or 15 volts probably, I already had probably like 40 or 50 volts high on the high voltage side. So that's all you do. Now originally, of course, this had a vacuum tube, but it doesn't matter. If it had a vacuum tube here, or in this case there's 4 diodes on the underside, what you want to do is just basically attach a DC voltmeter to the output of the rectifier circuit, or you know, your diode tube or diodes, and see if you've got high voltage. If you're turning the voltage up on your AC power supply and you're not getting any voltage here, you've apparently got problems. Now, of course, this is a vacuum tube, so it's going to have some power before it's going to start to conduct and work. Where this one being solid state, the instant you break the forward voltage, which of course is going to be very low, as soon as you hit that, it's going to start producing high voltage. So yeah, it's just a matter of check for voltage. And then also what I like to do is, as soon as I start to see high voltage, once I get to around 50 volts, I'm going to go to every single high voltage electrolytic capacitor in the radio and check and see if I have voltage at them. Large high value capacitors are usually, a lot of times, will be run at different voltages, so they'll go through usually like a voltage divider circuit to step the voltage down for use in different parts of a radio, you know, different circuits that need different voltage levels. But what you want to do is to make sure that all of those are correctly wired as well. So, you know, check your main rectifier circuit output. As long as it's good, then you can just go through with your voltmeter and probe at each of the high voltage electrolytic capacitors, and as long as you see voltage there that's either approximately the same as what's coming out or a little bit less than what's coming out of the rectifier circuit, you've got a pretty good feeling everything's okay. Everything looked fine. I just kept turning up till I got to 120 volts AC. High voltage was at about 350, 360 volts, I think, so it looked good. I stuck the tubes into the radio, fired it up. I had a little bit of sound out of receive. I wasn't even worried about transmit yet, and then the sound went out. And then sound came back, and I'd go to stand the radio up, and it would go out. I'd set it back down, and it would come in, and it would in and out, and it was noisy, and then it wasn't noisy, and it's like, oh my god. And this is where the nemesis, it just, this radio just killed me. So let's actually turn it off. And actually, that's another good thing to bring up if you're working on tube radios. Just because you've turned off the switch down here and unplugged the power cord does not mean this radio is safe. This thing could still, well, at least for about 30 seconds, at least in the case of this radio could still lay you flat out on the floor. These high voltage, fairly high value as well, electrolytic capacitors can store charge for a long time. Now this radio, in about 30 seconds, by the time you get to about 30 seconds, most of that voltage or that charge has been bled off just by design of the power supply. There's resistors in here that it can find a path to ground though. Where some radios, and not just radios, televisions, amplifiers, could be anything electronic. That's not the case in all things. A lot of times you can turn off something and come back a week later and there'll still be 400 volts on an electrolytic cap, and you go into it figuring, oh, it's been off for a week, it must be safe, and you touch that with your finger. Well, you get a really nasty, you either get a nasty bite, or worst case scenario, it could kill you. So just always remember, just because it's off, just because it's unplugged, does not mean it's safe to go touching components on the underside of the radio. Be sure you take a voltmeter and check from your chassis ground, or wherever the ground, whatever the ground reference is, and those capacitors. Just really quick, put a voltmeter. No voltage, no voltage, no voltage, no voltage. Okay, it's safe to work on. Now you know you can touch anything in the radio, and you're not going to get laid out on the floor. So this one's been off for over 30 seconds now, so I'm confident that all the voltage is bled off. Because trust me, I've had this thing turned on and off and on and off, and right side up and upside down, and flipped back and forth. God knows, it's a wonder I haven't worn the chassis out as many times as I've had to flip this thing. But so you saw the electrolytic can cap had been replaced on top. There's a few other ones, one here, a little small one here, another one over here. This only had really one paper filter cap. That's this yellow one here has been replaced. So actually, here are all the parts, except for the vacuum tubes. I did end up replacing, what was it, the final tube and both audio tubes. But here's all the original parts. And you'll see something in here you usually don't see in this pile that I replaced a few of that I would normally never replace. It's ceramic capacitors. And actually not just ceramic capacitors, also a lot of low wattage resistors. Usually you won't see me doing that. Usually the only resistors I'd replace would be like that one, and that one. I guess like 3. So 3 larger wattage resistors. And that would be it. Pretty much, that's electrolytic cap. Those caps would have been changed. Now the diodes, here's the original diodes that were in it. You can see nice big clunky ones compared to the little teeny tiny ones that I stuck in there. Yeah, those little black specks right there are the diodes compared to these big original metal packages. But like I say, these, yeah, just in my experience here, they've gotten to the age where these things really aren't that reliable anymore. Diodes are so cheap nowadays, you know, silicon rectifier diodes. Just pop in some new ones. It's cheap insurance. These things are ancient. And like I say, early semiconductors, they're nowhere close to as reliable as modern day ones. So you know, electrolytic caps were replaced. So here's the 3 electrolytic axial caps and the can cap, which is multi-section. Now this is a 4-section electrolytic capacitor, but they actually only used 3 sections of it. Here's the 1 paper cap. So this is actually a paper cap, but one thing to note, it's 1 microfarad, but 200 volts. That's a big honking capacitor. Well, actually, the one that I installed in here, it's the same value. It's 1 microfarad, but this one's rated at 630 volts. And look at the size difference. Yeah, this thing just dwarfs that one, and this thing's over 3 times the voltage rating. Says a lot about technology, how far we've come with components, how small we can make them nowadays compared to the old days. But yeah, so that was replaced. The slow blow fuse, this does have 2 different fuses. It has a 1.5 amp slow blow fuse and a 15 amp fuse. Now, when you have the radio attached to an AC power cord, the AC voltage is actually going through both of those fuses. When you're running the radio off of DC, it's only running through the 15 amp fuse. It's just the way they have the switch wired in this. When you have it in AC, it runs through the 15 amp fuse because it's in circuit there. They just kind of had to use it. Or they'd have had to come up with a switch that had multiple sets of contacts, and that would have added a lot of wire and complexity to the circuit. So yeah, they just left the 15 amp fuse in circuit when you're in AC. But this fuse was causing me problems. Radio wouldn't be on. This was one of the first problems, was radio wouldn't come on. I found that if you tap the fuse, radio would come on. You'd tap the fuse again, radio would go off. You'd start to lift the radio up, that's when the radio would come on and off. So it's almost like the filament in there is probably broken loose from the end of the cap. So yeah, fuse got replaced. Antenna connector got replaced. You can see about 1/3 of the insulator inside there is broken out, so that was replaced. Of course, the big resistors. Now, once I got to a point where I had the tubes back in it, I was making sound. The audio didn't sound that great, but I hadn't done an alignment on this yet, and that's not that hard on one of these because it's kind of limited on adjustments in one of these. But I had just, like I say, the receive audio was so-so. The transmit audio was horrendous. It was just, yeah, forget it, useless. The louder you talked into a microphone, the worse it got. If you whistled into the mic, trust me, on a receiving radio, it didn't resemble anything close to a whistle. It just resembled, you know, crinkling paper, basically. That's about it. So I went through and checked a lot of these resistors. Now, normally, I won't change these. You look in a radio like this, there's still a lot of these small value resistors in here, and I can guarantee you probably quite a few of them have drifted out of tolerance. So, you know, depending if it's got a red, a gold, or a silver band as the end band, that's your tolerance. So, you know, it could be a 5, 10, shoot, they could even be 20% resistors. I can guarantee you some of those are probably out of tolerance, but honestly, it won't affect the circuit. In a lot of circuits, the resistors are such a high value to start with, they could increase by, you know, if it's a 1.5 meg resistor, in some circuits, shoot, if the resistance increased by another half meg or more, it honestly wouldn't affect performance. Where in audio circuits it can get to be or anything that has a lot of stage gain, resistance values changing can throw off the amount of gain. But that's one of those use your judgment. If you turn a radio on and it seems to be working fine, then there's no need to change them. Even if they have drifted slightly out of tolerance, they're still within a range that is acceptable for the radio to perform good. But yeah, I was having audio problems. One, or it might have been two, I honestly can't remember right off the top of my head. One or two of these were noisy, which meaning I used my signal tracer over there, which has a, so I'm referring to that guy right there. That has a noise test feature built into it. Now, if you have a signal tracer like that, doesn't have to be that make and model, but if you have a signal tracer and it has a noise test function, be very careful when you're using it. This one, I think the Heath kits put about 100 volts on the probe. This model of this tracer, this is a Paco, it puts about 150 volts DC at the probe tip. So that the tip that you'd normally be probing in a circuit to check for a signal, it basically reverses that. It puts it puts a DC voltage on there. It's still checking for noise, the AC signal coming out back into the probe, but it's got a DC voltage there. And what that does is, the idea is, for stuff like resistors, they get noisy. Sitting here, it's fine. You hook it up to an ohm meter, it might test fine within tolerance. Shoot, it could be spot on, you know, whatever resistance value, you know, you happen to have, it could be perfect. But they can get noisy. They can actually start to break down internally, and when you start applying a high voltage to them, you'll start to get crackling, that crunchy noise like I was talking about. So what you do is just apply DC voltage, and that's what the noise test in those signal tracers is for. It's basically meant to find noisy resistors. So you just clip the ground lead on one side, you would attach the probe to the other side, and I'm not talking about taking them out of circuit. You do that in circuit. Now, of course, you wouldn't want to do this to a solid state radio. Yeah, you'd probably fry parts, most definitely. But old vacuum tube radios, everything in here is high voltage. And that the voltage that's coming out of the probe tip on that is also current limited. It's like 1.5 milliamps is the maximum current. So if you dead short the tip of the probe to ground, you know, to the ground clip on that probe, you're only going to have like 1.5 milliamps of current at 150 volts DC. So yeah, it's not even if the voltage may be a little high, the current isn't big enough to hurt anything in here. But yeah, I did find, I know there was one, might have been two, but I also found a noisy ceramic cap. So that's also why there are several ceramic caps down here. Normally, again, I don't change ceramic caps. They're usually very reliable, especially later ones. But this is an old tube type radio. So one of, I think it was this, might have been this one, was the noisy one. And this capacitor is actually, we'll just find it here on the schematic, is that one. Right there attached to the RF final amplifier tube. So where that's attached in circuit, you have your modulation transformer. So your audio comes out, comes over, down. Here's a 0.002 ceramic cap to ground. Also goes up to the output transformer here, but goes over through a 22K resistor, and that's what's feeding the audio into the RF amplifier tube. This capacitor is attached between that point and ground. And yeah, apparently this thing had gone noisy as well, because I replaced the resistors. My noise problem got a lot less, but still, again, if you'd really loud talk into the microphone or you whistled, that noise, that crunchy, it wasn't as bad, but there was still a crunchy, crackly noise there. And I'm not sure actually what they used. I don't think these are ceramic dipped, because this is a ceramic capacitor. These red ones, these are ceramic capacitors. These are ones that I installed, and these two back here are also ones that I installed. These, like I said, I'm not sure what they made them out of. These ceramic caps, if you ever try and break them, they just shatter, the coating that's on there. So it was in liquid form, you know, they dunk it in and it dries, or they bake it onto them. But it's a ceramic type material. But it's very crumbly, kind of reminds you like concrete or a rock. You can just keep breaking it into dust and it'll just crumble. This stuff here on these capacitors, it kind of reminds me almost of like some type of phenolic material or some type of fibrous material. It's not asbestos, but if you break off a piece of the brown outer coating there, you can see fibers in it, and it doesn't break apart real easy like the coating you'd see on these. It kind of crumbles, but it's actually a little bit more flexible. So I kind of get the feeling it might be not quite as water repellent as what they use on the little bit later capacitors, and of course, you know, modern style capacitors. So yeah, it might have just been moisture got into this thing over the years and it started to short out between the plates. So, but yeah, I just kind of loaded up the shotgun. Anything in the audio circuit, if it was a resistor or a ceramic cap, it got replaced. I wasn't going to take a chance, because it's like I say, you replace a part, there's, you know, a bad part, and there would still be noise. You'd replace another bad part. Yeah, the noise problem's getting better every time, but there's still noise there. Eventually, you just get to the point where it's going to take less time to just replace all of these than it is to go through point by point trying to troubleshoot and find a problem, replace one part, turn the soldering station off, turn the radio back on. Oh God, there's still a problem. Go in, do some more troubleshooting, find the next noisy component. I'd just replace all of these and be done with it and guarantee then I'm guaranteed all the passive components have been changed in that circuit, because honestly that's not that many parts. But then if there's still a problem, well, I'm guaranteed it's not the audio circuit, because I've replaced basically all the passive parts in the audio circuit. And actually this capacitor, I replaced it. I've seen caps like this before. I don't like it. When they dip these things, and this is kind of a dead giveaway that they're dipped. You see that little ear sticking off there? That's because when it was dipped in and pulled out, it was probably left hanging at about that angle when it dried, and that's where the little drip was coming off of it. But you can also see it wasn't dipped completely. You can see, if you take a flashlight, you can see almost the whole way in through this thing, the whole way up to the top of the cap in there. Because I did shine a flashlight in there and look at it. I don't like that, because like I say, not only can moisture get in there and cause problems over time, shoot, a piece of metal could get up in there and short out between the two plates. So yeah, that was this one right here, this big 0.04 microfarad cap. So yeah, that's why that was replaced. Not because I suspected it of being noisy, but because it hadn't been completely sealed in the coating there. So like I say, I got all those replaced, and then my noise problem was pretty much gone. Then I did the alignment, and the radio's working good now. Now these are not power monsters. If you look at the schematic, there is no driver and final tube in this for starters. It's just using a 6, I don't even know if it says on this schematic, 6CX8 final tube. So yeah, you've got the transmit oscillator, which is the oscillator tube for the transmit crystal. That goes to the final tube, and the modulation. That's it. There's only one stage of amplification for RF output. Again, with the audio, there's not a huge amount of audio amplification here. You have a 6E, now granted on the schematic here it's shown as a 7687, but I've never actually seen one of these with a 7687 in it. They always have a 6EA8, which is what this has, and one of the ones I replaced. But that's a dual section tube, so the first section of the tube is used as the speech amplifier for the microphone. And then when the radio's in receive, the only thing it uses is the second section. So the second section uses an audio amplifier, and that feeds the 6AQ5 output modulation tube. So that's pretty much, like I say, very simple, limited number of tubes, so limited power. These things are not power monsters. But yep, there it is. Kind of interesting. Where do I have that? There it is. You notice that kind of cool little graphic they had on the speaker grill? Well, here's actually an advertisement for the radio. First, for starters, let's take a look at the price. This is a scan of a magazine article from August 1962. $199.95 in 1962. you account for inflation. Now, I did not do that. I haven't gone to the government, inflation calculator and figured out what the inflation what it comes out to. But I'd almost have to guarantee you $199.95 August 1962 would equate to most likely well over $1,000 today. So yes, stuff like this, you didn't just on a whim, or at least the average person wouldn't on a whim decide one day, I'm going to go buy a CB today. This was a big investment back in the day. The other thing to note here is, well, you talk about some racy artwork. Yeah, that just wouldn't fly nowadays, but that's definitely not a publicly correct advertisement. But again, that's the way things were back then. We've advanced, or at least most of us have advanced as a human species. There's still some Neanderthals out there, but we're doing our best to get rid of them. But so let's take a look at the back of the radio. So you can see here's the crystal complement. This little cover goes in there and then the screw goes in. Now the cover is actually, I don't want to set it on the knob, so I'll hold it up and I'll point to it with my thumb. But you see that gap right there? That's because I had to replace this connector, and actually it was like that before I started. It's kind of weird the way they put the RF connector in this radio. There's two pieces of sheet metal here. The inside one is the steel sheet metal chassis. The back is an aluminum plate. But the RF connector is only attached to the steel chassis. Now from the factory it had two rivets right here. But of course it has rivet heads, and they bulge out past. We've got a piece of flat sheet metal they're going to sandwich over top of it, so it buckles the rear out. So yeah, it was actually like that before I even started. So yeah, I took the old one out and replaced it because it was broken, put it in with screws and nuts with star washers. So yeah, that amount of bow, that's actually about how much bow there was there when I started on the radio. But yeah, there's the, and you can see this actually has the pins sticking out the back. But there's that oddball plug, and what is that, 12, 13, 15. It's a 15-pin plug, so it has 3 big terminals in the middle, and then it has 2 rows of 6 small terminals, and they're offset a little bit, and just like the big pins, these 2 pins are spaced close together, and then there's a large gap, so you can only plug in that plug over there in one direction. Now you'll notice on the crystal complement here, we have 6 crystals marked transmit and receive, but there's only 5 transmit crystals. The reason there's only 5 transmit crystals is when you were looking at the front of the radio, notice there's a crystal socket sticking out the front of the radio. That's what this wire coming back right here is. It comes over and attaches to where this crystal would normally be in this radio. So what you do is you leave this crystal out. It's because you could only have 6 channels. Now you can receive on all 23. This has a slide switch on the front for crystal or VFO. So you can turn this air variable tuning capacitor here to tune in when you're in VFO mode. But when you switch into crystal, you'll have crystal controlled receive, and then when you turn the knob, that would also be your transmit. But you can only transmit on 6 channels with this radio. So what you do is you'd put, if you wanted more than 6 channels, you'd install 5 crystals in the back of the radio, and then your additional crystals, whatever channel you wanted to transmit on that you didn't already have installed here in the back, you could then just plug into that socket on the front of the radio. So that's why they did that. That's why there's a missing crystal here. That's so you could just plug it in at the front of the radio. Speaker connection, you could use an internal or external speaker. Now there is a shorting bar across here, and you can see it says common, external, internal. So the way this is wired, the output modulation transformer goes to the external speaker jack. So when you want to use the internal speaker, because the wire from the modulation transformer comes up to the external, if you want to use the internal speaker, you put this little shorting bar in here, and then there's a wire that goes from the internal terminal here up to the speaker. If you want to use an external speaker, you remove the shorting bar, and then you detach your speaker between common and the external jack. So yeah, not a lot going on back here. As you can see, it is the actual model number is 91-02, and if I zoom in here a little bit, you can see they actually hand engraved the serial number and chassis number on there. So, you know, hand built. Yep, this is a US. This is back when everything was made in the USA and built by hand. So yeah, this is a Chicago, Illinois radio. One thing I've noticed is the only thing I still have to do to this is I have to pull this meter back out because the needle is sticking a little bit. It's not a tension problem. I can see the needles, I guess, just being over, you know, what, 60 years bouncing around. The needle looks like it's a little bent and it's rubbing the actual, you know, the scale in there a little bit. So I need to disassemble that thing and just pry the needle out just a hair so it's not rubbing anymore. But there you go. There's pretty much an overview of the radio. Like I say, I need to pull that out, fix that. And one thing that's kind of nice about that actually is they just unplug. You don't even have to desolder anything. They have push-on terminals. So just pull those two terminals, pry out the little clamp right there, the meter falls out. Oh, there's the two fuses for the radio right there. And the cardboard, like I say, I keep cardboard on the speaker anytime I'm working on something and it's not covered so I don't poke my finger through it. That's always a good thing to try and remember. Always cover up the speaker. Trust me, I found out the hard way years ago. This was one of my own radios, but yeah, I did that one time. Actually, I think it was my thumb went through a speaker, and from then on I've always taped a piece of cardboard over the speaker. So... But let me get this meter fixed up. I'll get it shoved back in a cabinet, and you can see what it looks like in a nice shiny chrome cabinet. Okay, so here she is all back together now. I think it's too late for a daytime skip, and it's too early for the evening guys. Yeah, none of the locals are on. Nobody on 12 or 17 yet. But anyhow, there you go. That's what she looks like put back together. Like I say, the chrome cover, looking through the camera, it doesn't look, actually, especially like if you look over here, it looks amazing over here. But you can see over here, you can see, it's, like I say, it was horribly pitted with just lots of little teeny tiny chrome pits and had that nasty film just, yeah, baked on atmospheric gunk on it. So I got all of that off and it looks a lot better. I think it actually looks better in the camera right now than it actually is. Like I say, you kind of get a better, little bit hazy. It looks really good over here because there's no direct light reflection on it, but over here where I've got an overhead light right there, you can kind of see it. But it does look good. It's one of those things from 3 feet away, it looks fantastic. If you get up really close and look at the chrome, you're going to notice the imperfections. But unfortunately, there's nothing you can do for that other than get it re-chrome plated. And yeah, sending something like this off to advanced chrome plating to get redone, you'd probably be looking at, if I had to guess, $400, maybe $500 to get something like that chrome plated. So yeah, that's big expense. So it's definitely better than it was. One thing I did notice I had completely forgotten about until I actually got it slid back in the cabinet. I had it sitting here and I looked at it and I was like, oh nuts, I forgot to put an aluminum trim ring on it. It had the trim rings for the volume and squelch controls and the channel selector, but it had the center disc, but it had the little ring that goes around the outside was missing. So like most radios, I did have a parts chassis, so I was able to pull the trim ring off of a parts chassis, polished it up and stuck it on there. So now it's complete because it was missing that before. Like I said, I just completely forgot all about that little thing till I got it completely back together and noticed one was shiny and one wasn't. So there you go, the Utica T&C II.